Would have been expecting this anyway. Everybody saw this?
Yes, sir. So I was saying the same thing is basically what we expected.
Yeah. So as I always tell you, that this part would have been, I think, okay. I mean, we were expecting this source of hydrocarbons. Actually, I did I sent a question on that. All right, so and then there was this one as well. So organic chemistry and introduction. So and the reactions of carbon compounds. So this one question would be on this. This is pretty much one question. If there are gonna be 6 questions on the paper and you have 10 topics, one of the questions will take care of 6, 7, and 8. Which means that they will have a question. They could merge these two to make one question. The only qualitative analysis, non-metals. This could be one question as well. So I was saying some persons that might as well send the paper because they might as well just send the questions and done, because you narrowing it down like this. If you're smart, you know which things to focus on. They actually see in that atomic structure, periodic table, periodicity. That's one question. No, this is for paper 2. All right. And 2 persons in the waiting room. Let's see what's happening.
So they're not going to do that for paper 1 because paper 1 is going to be about everything.
Exactly. I couldn't see the persons in the waiting room. Who are? Was it Michaela? And January again. All right. Yeah. All right. So. All right. So then, no, we're not worrying about paper 1. That's paper 1 is just I mean, what I expect CSEC to do with paper 1 is probably use new questions and then that sort of going put more pressure on the student to perform. Paper 2 would be like last year's paper 1, like when they do it like this, where everybody sort of know what is coming. Everybody prepared. And it was hard for them to decide who must get 1, 2, or 3 because everybody did well. This year now, paper 2 is like last year's paper 1. They just send the topics come and then everybody have like study the same thing now. And then it's a competition. Will be there to see who perform the best. No, that is who actually do the best. Then when set the grade 1. And that's where it is. So you're basically competing against other persons when they do it like this. So this is good information still. All right. Acid base and salts, mole concept. That's one question here. Remember that we have 6 questions. And this is 1. This will be 2. All right. This could be 3. This is a electrochemistry, something by itself. This could be 4. That means, what it means here, you could have 2 organic chemistry questions. Certainly, let's put this for 6. 1, 2, 3. All right. There must be a 4 here. Question 5. So this is looking like 2 organic chemistry questions. So that's what happened. I think that's happened last year. 2 organic chemistry questions. Which means that they're going 2 places with organic chemistry. They're going into the basic stuff. So they're going into the basic stuff, and they're also going into the they're going into the more advanced stuff in organic chemistry. So this is This is important stuff for us. So we actually we might not know the order of the questions though. And that's one thing you must remember. So don't say sir said it's going to be the first question. No, what we are looking at is the questions. We're not looking at the order in which they were inputted. Because to figure out the order now is a different thing. Actually, this one I have as number 2 looks like it could be the first question. Reason being, the first question will be a graph, and out of all of the questions that could be graph questions, it looks like, well, 3 and 4, they can tie these together easily into one question, and so that would actually make it very likely for question 1. I mean, it's like they could give you a titration lab here, but they didn't specify titration. They said acid, base, and salt, but I understand that this could also include titration as well. And of course, getting a table to fill out and even plotting a graph as well. So this is good. This is good information. They leave off some things that would normally be on a paper. So this kind of help us that way. They say they leave out rates of reaction and them leave out oxidation reduction. And them leave out that. Which if they're using fresh questions now, it could be that those questions will be on paper 1. So that this is something very useful for us, guys. Something to really consider here. You guys have any questions?
No, sir.
Yeah. All right. So now in terms of that first question, is very likely. I'm not saying where atomic structure could be the first question or periodic table. There isn't really anything of a graph to ask about it. So yes, all right. So possibly titration. All right. Possibly, well, titration curve. And they didn't say energetics either, so therefore it couldn't be that type of graph as well. So this is interesting indeed. That's the only way the mole concept will come in here. So so look over that, which will carry us back to a question that we and let's look at a sample question here, which was actually the sources of hydrocarbons were asked here. All right, so what we can do here is can go through and tick off questions that will be in line with what from past papers that look like what them saying. So all right. And there's also equal 6 questions actually equals 100 marks. So it's possible that this one here, let's highlight this in red. And they will carry this is as it's question 1, so it will be 25 marks. It's actually predictable. All right, so 25 marks. Which basically means this will be 15 marks. This will be 15. This will be 15. And then this would be 15. So we actually know how much marks each question we can carry here. Out of all those, it should get 100. Paper 2. If you pass paper 2, and SBA good, then basically you pass the exam. The lowest grade you could get there is a 3. And that's if you basically don't do anything on a paper one. So this is where it is, guys. All right. So the part 3 and 4 look like something where we need to explore in some detail here. And let's look at the recent questions. And I've seen, well, as a first question, this was 2015, I believe. So let's just go back to 2016 and see what they send that here. All right, this was 2016. So it wouldn't be like this one. All right, so I think they're going all questions in. That's what they're doing, all questions. So look like we have to go back to like 08. We'll go back in 08. All right, this one no. Yeah, it's more like it. We find something similar to that fit that. Yes. Yeah, this question is a good fit. It fit right in there. This is 25 marks. So all right, this is something that we should work. Let me yeah. Except that this question don't have anything about salt. But still, acid and base there, them ask both. All right, so what we're gonna do here now, we're gonna just compile this. And as you can see, this is a lengthy question. All right. I don't know if you see a picture. All right, remember I did then. All right, probably can go through it. Can go through it. When you everybody seeing it?
Yes, sir.
All right. So the instructions here. Don't spend more than 30 minutes on question 1. That's something that that they recommend. All right. So that is it now. Question 1 says it is impossible. It's all right. So it is possible to determine the endpoint of a titration. Now, it's actually really specified titration, but them say acid-base reaction. So you automatically know say that titration here. So underline that part by measuring temperature changes when different volumes of strong acid react with a strong base. We're going to underline strong acid and strong base. We're looking for the key terms here. All right, table 1 shows the volumes of sulfuric acid used to react with this amount of that. This is so sodium hydroxide and the temperature changes that occurred. So this is showing here the readings for the addition here. All right, so all right. So guys, 25 centimeter cube here. All right. You see anything with numbers here, you have to take them seriously in these questions. So we're going to underline these and we're going to use them. I remember that I said for chemistry now, there are 7 formulas you would need to know. But hold on. This is because I can give you the topic them now. You don't need to know all 7. Let's take up in here. This page is 325. I'm gonna mark that page 325. All right. And I wanted to get everything on one paper. It's probably down page 500 and something. Yeah, right here. So we're trying to find now 530 something. I think I put that page here. Right here. 538. So that's 538. All right. So all right. Let us let's get rid of the calculation part first and work up from there. If they're asking about atomic structure and mole concept, they have a few formulas here. So let's write important formulas. Important formula for chemistry. All right. And they based on what I'm seeing with these topics here, they expect you to know this one. All right. And of course, we're going to need to know them term. If them say mole concept kind of vague. So we have to go expand that as much as possible. But this is the mole concept. Actually, this is it. So we're gonna have to explain this a little bit. But this formula is important. All right. All right. So they're gonna say, so this is the mole concept here. So what this is saying, or let's see, it is actually a mole concept equation. All right, so the mole concept formula. All right, what I'm also like to do here is combine it. Well, they didn't, if they say mole concept, no, then could also ask about number of particles too. But let's assuming that they're not going there. All right, this is usually for titration purposes here. You have the moles and you have the volume and you have the concentration, which it's also called molarity. All right, so again, we're going to come to these formulas. Volume usually measured in dm cube. So as I was saying in the previous class, that when you say anything in cm cube, you're going to convert it to dm cube. But then based on these topics, this formula will be used. You're going to have to use this. So you have to get practice with this. All right, the mole concept family. This one, anything will involve calculating moles. And I want to also tell you that it could also turn up in electrolysis, which means if they got electrochemistry, more than likely you're going to apply the mole concept another way. Which in fact all of the main formulas in chemistry involve the moles. But then let's see now. Another trick here is we're going to learn about something called, well, I'll show it to you here. Just move this line. All right. It's really not getting that much more. But all right, so let's go now. So it's gonna be for the coulombs per mole. So it's gonna be the number of moles here. And then you have the Faraday here. So this would be 96,500. Yeah. So 96,500 and coulomb per mole. And then now we divide this by the charge. All right. So charge, quantity of charge, by the way. So this is something where, and as we said, this will be in electrochemistry. So when you look at the topics, these formulas would be used in like in one topic, and this would be used in another topic. But what they will try to do, as we said, they're going to try to merge questions together. So all right, so that's charge, and then charge is measured in coulombs, And linear divide coulomb by coulombs, leave it with the mole there. So actually, this is the number of moles. All right. Now, there you go. So this exam, guys, overall, even though them sending 10 topics, is it? Or yeah, they send 10 topics. It is telling you that the mole concept will be very important to pass or to do well in those 10 topics. All right. And these are three equations that you will see in the exam. And we get this information just by looking at this and applying common sense here. All right. Anybody have any questions?
No, sir.
All right. So when you leave class, pretty much what they are saying to you, and this is between now and exam, that focus on organic chemistry. You want to spend maybe, I would go ahead and say, all right, you want to spend close to half of the time that you have left on organic chemistry. All right. That is evident because we are seeing here that 6, 7, and 8 potentially could be 2 questions. Those 2 carry 30 marks. All right. The electrochemistry and 3 to 5 is actually testing on these 3 formulas here. So for questions 3 to 5, or rather topics 3 to 5. I don't know why it's taking so long to erase. I just want to erase it like that then. All right. So since topics 3 to 5, we'll cover this. All right. So 3 to 5 cover that. Organic chemistry, no one them thing there. There is really no formula. Just a lot of concepts here. Sources of hydrocarbon. Them why you figure know about you have 3 sources of hydrocarbons, by the way. So you can just write them here. So they might ask something about it. So you have your crude oil, you have your natural gas. These are the 2 main ones. And of course, the third one, which people tend to sideline a lot, is coal. So when they ask about sources there, those 3 of them you have. All right, so that's out of the way there. All right, and we say I did actually show you a question that looked like what they could ask for that, which see this is a sample of a question which come with the sources here. So natural sources here. So automatically you would have just write out all of them just tell you a while ago. All right, you have natural gas, you have crude oil, and you have coal. So solid, liquid, and gas there. All right. Everybody get that?
Yes, sir.
All right. So let's go solid, liquid, gas here. And that will give us so coal. And we could also call it petroleum. And we could also call it natural gas. All right, so those are 3. All right, so all right, so All right. So then they go on to ask you about the processes here. So if them ask about the sources, just know so them are gonna ask about how you can process the you can actually process petroleum. That's they go on to ask about fractional distillation. That's a key term there of the crude oil. So it's like them give you part of the answer in this part of the question, next part of the question. So then referring back to this one. And then this is a popular question they'll ask. The how you can separate the crude oil into different fractions. All right. I think I have some information on that. So when you send that, it was actually on another slide. Or I believe that it was sent before. I think let me just go back to it. Where is it? Okay. See now. All right. So let me go here. Oh, never go into the sources. We just tell you about the homologous series and so on. So this would even come before that. This has to do with the fractions them. All right. So I'm going to summarize the fractions them for you now. So crude oil fractions. So and then you're going to see an image showing all of them. In fact, what you need to know here is the amount of carbons in each. So then say number of carbons here, C1 to C4. So this is saying that if the crude oil, and I'm going to show you that process here in a second. So right here now. All right. But seeing this?
Yes, sir.
All right. So this is actually crude oil distillation. All right, crude oil distillation. And you have C1 to C4 being gas. But they're actually showing you what happens as you go down. So again, we don't know what specific questions they're gonna send, but this is useful information simply because they tell you that they're going to ask you about the sources. And one of the sources of hydrocarbons is actually crude oil. So we have gases here, gasoline, naphtha, kerosene, diesel, lubricating oil, and yeah, and of course you have fuel oil here. This is what you use for like probably maybe airplane or something like that. The bigger machinery or vehicles here. All right, so of course I'm telling you that crude oil going and it is heated. It is heated up to 400 degrees. All right, so and of course when the vapor rises now, the vapor is collected at different parts of the tower. So it's like they build a huge tower, a very tall one, and they put the crude oil in close to the lower part of the tower. And when the heat is applied to it, it separates into different parts, which the thickest one, that's why them say the viscosity and the boiling point decreases as you go down. So yeah, the thickest part will actually go to the lower part, and that becomes bitumen, which is actually asphalt. This is what they use for road surfaces. Paraffin wax is like candle. And so candle is made in this way. So you get crude oil, they just get it from below the earth, below the sea. You drill it, and then you use whatever machinery to make it come up. So it's gonna be like a black fluid. So if you don't know what crude oil looks like, then here is an image that should help you. All right, there. All right. First of all, you're gonna dig a well, and usually when you're mining or you're extracting oil, um, a lot of the oil looks like this. It's black, thick liquid. Um, so that is what crude oil looks like. All right. So if you haven't seen it before, here it is, and there's another image as well. We could actually use this. So that's the type of texture you're looking at for crude oil. All right. So this is a source of hydrocarbon. So crude oil. So now this black liquid is sent into a tower and heated up to 400 degrees, where different parts of the liquid become separated. And the part that becomes separated, each part that is separated is used to make something different and also looks different from each other as well. So, for example, asphalt looks different from candle wax by far. Um, in fact, the candle wax look more white and then the asphalt look more black. So, from something black, you can get something white. This is amazing. All right. Then now, the vapor, when the heat is applied, the vapors that rise now will form different things. And say up to C, from C1 to C4, you're getting gas. That's at the coolest part of the tower, which is at the top. You know, hot air rises, but as it rises, it cools. It's passing through different parts that tend to cool it down. So all the heat energy becomes, deposited. And so by the time it reach up here, it's so cool. And then you get like very small carbon compounds here that are gases. So C1 to C4, and then gasoline is C5 to C6. Naphthalene. You probably know this as camphor ball. But that's what that naphtha is. And we should know kerosene and diesel, So that's what they mean by the fractions, guys. This is the distillation. All right, it is fractional distillation because it is distilled into fractions. All right, that's pretty much the concept here. Any questions here, guys? Do you understand what is being said?
Yes, sir.
Okay. Tara, still there?
Yes, sir.
Okay, that's cool. Shantai and Daniel,
Yes, sir.
Michaela is still there?
Yes, sir.
Yes, sir.
All right. I think Janari, you having problems there. The microphone.
Okay, sir.
Okay. All right. Suppose Shantai is there as well. So, all right. So then let us proceed then. All right. So we cover the sources and what they could possibly ask here. Look at what they asked in this paper. Identify one of these numbered fractions. And let's say, all right, them say one of them. It's like you want to tell them which one and say what is it called. So going back to this chart, that's easy. C1 to C4, what would you write for that here? This is the fraction number here. Identify one of them. So it's if we're going to identify the first one, what would be the name of that? Class, what would be the name of that?
Gas, sir.
Obviously gas, but that's what's shown here. So therefore C1 to C4 is gas. That's the name we're going to give to it. That's all they're asking you to do. All right. But then you didn't have to write 1 as the fraction. Them say identify 1, which means it can be anyone. What if you didn't choose 1? Suppose you choose the second one. What's you choose the second one?
So it'd be either kerosene or diesel.
Okay. So that's what you're right. All right. Let's go back to that then. If you choose the second one, all right, if you choose the second one, so let's say you choose the fraction 2 here. All right. So you get that there. You see I have C12 to 18 there. Let's go back to the chart. The C12 to 18. And you were saying kerosene or diesel. Yeah. I mean, you get the marks for that. All right. So this is what they wanted to know here. All right. C12 to 18 can either be kerosene or diesel. All right. So, and then of course, you also had another answer that you could give. If it was 3, what would you write? If you chose 3 as a 1. Well, 3C20 to C40. So which one would that be?
Lube oil or fuel oil.
Yeah. So I mean, that's basically it. So this is how you do the question. So all right. So that's pretty much it, guys, for the sources, I mean, they can ask you the uses and they can ask you the name. Which this part of the question asking you for the state 1 use of fraction 3. So even if you didn't give fraction 3 as your answer, I'm still going to ask you that. And they want to see if you know all of them. So C1 and C2. All right. So say if we scribble it down there, so no, this would be natural gas or scarlet gas. And then you just say here, so it's could be kerosene or diesel. All right. And you say C20. You would say what? Lube. Well, yeah, lube oil. Lube oil, and which one you say?
Fuel oil.
All right. So yeah, that's basically what this is asking about. All right. So now 1, 2, 3. Fraction number 1, 2, 3 there. All right. So all right. All right. This is not expanding as how it should. Don't know what's happening. All right, there you go. All right, so then 1 use of fraction 3, as I say, just write lubricating. That's what lube oil is, lubricating surfaces. And then of course you have you could say our fuel. That's why I'm say 1 use, because you have more than 1 use. So that's that. So again, does that knowledge alone could help us here for this topic. sources of hydrocarbons. That's what the questions most likely gonna look like. So by knowing all of what I show you, especially everything related to this diagram here, that's number 6 and the list of topics that CSEC sent. All right. And so what we could do here is just spend time on each of these topics and look at the past paper questions that resemble what them say here and get ourselves ready for the exam. So that's that. All right. Of course, them even say for 7 is an introduction to organic chemistry. So when them say an introduction, expect that them when ask about alkenes and alkenes. And when them talk about reactions now of carbon compounds, it could be most likely alcohols. Most likely this is where alcohols would be needed. There's a lot of reactions here. So they are giving a lot of hints in this exam. It's looking like 2 organic chemistry questions. And if it's, well, there's one scenario where they could combine 6, 7, and 8 into one question for 15 marks, which means if they combine 3 topics for one question to give 15 marks, an average of 5 marks per one of these. So if you check the number of marks you got for a while ago for the fractions, this is actually 2 marks for 2 sources. This is 1 mark for the fraction and telling you what it named, and then this is 1 mark. So it's something similar to this. Something similar to this, guys. I think they have a question like this on another paper as well that they sent. So you guys can be ready for this exam though easily. All right. So all right, so that's it, guys. So I won't spend too long with it because, well, most of the persons not here. Not sure what happened, but I had some delays. I wasn't even at home today, and I reached home late, so it really kind of set me back. You know that school start back today, but they're saying that I have to get this information to you guys so you see what is happening. All right, so what we spoke about today, as we say, we spoke about the topics them, right? Possibly questions which well, we know that it's 6 questions, but the 10 topics will be divided into 6 questions. And when they are divided now, as we say, we know that 2 topics will merge to form one single question, and that's a minimum of 2 topics will be in one single question. All right. And as you can see here, with this question here, we're not finished this question. This is a number 3 question from 2015. And the first part is talking about the sources, but this part now is saying compound W has a characteristic odor of pears and is used in the fragrances as a food additive. And they call it compound W. And they ask you to identify the homologous series to which, again, this is the introduction to organic chemistry. We're asking about homologous series. We did that in a previous class. But then, there's things you look for here. So this is going on to more of the reaction between. So this looks like the 7th topic. Let me see. Let's go back to it. It's like the 8th topic, reactions of carbon compounds, because when I explain this to you, you'll see that this actually is a reaction here. Now, I'll talk about this another time, but I just want to show you where they went for here. So like this part would be sources of hydrocarbon. if you can do this with the past paper then I mean just look good, just read them through and just highlight which topic it look like. That's a big help. So I'll have this. So if I were looking for past papers to help me with studying the sources, then you'll be looking for questions like these. Stop there. When you reach, reactions of carbon compounds, it would be here. And just say we're gonna go through all of them. And you're gonna see what really is taking place here. And today here asking you when it is hydrolyzed. So hydrolyzed is actually a reaction. It's a type of reaction. So, and also they could mention, but they didn't say polymers though. So I wouldn't be expecting to see polymers, although it's likely. If you're going to set organic chemistry paper and not set polymers, that's very unlikely. But that's something that we're not going to talk about just yet. We just want to see and have an idea of what, based on the topics, what has been sent before. All right, so that's it, guys. I would say this is just to show you what these topics really mean. It don't just mean say, well, all right, we get these 10 topics, so we just need to take up a book and read the 10 topics. No, and that's how it works. You have to know the things that exams have asked before and the topic, and prepare around that. So as me say, you work one question, you work two past paper questions, and on the same topic, maybe 3 if you can find it. Then afterwards, no, teacher turn it around. Say, what if they ask you this? What if they ask it that way? Once you can and turn it different ways and still answer the question, then that means you would have locked the topic. That's where you need to be. So just understand, say, sir is telling you that 6, 7, and 8 major topics to focus on right now, guys. So I'm say, if you're going to take up a book and read something, organic chemistry is something that I would say is the most readable part of chemistry. If you want to take up a book and read something in chemistry, organic chemistry. In fact, that's how I started to learn it. I just read a book one summer when I think I was in third form, and I just took up and just read it, and then it just stick after that up to this day. Still remember what the book looked like. I still remember everything about that book. It was just talking about organic chemistry and just reading it, telling you like about the oil and all that sort of stuff, and what type of compounds you get from it. Tells you where the gasoline, the gas that you use on your stove is actually up here. In fact, this is actually cooking gas. But we just call it natural or cooking gas. Natural gas, by the way, natural gas is a lighter form of cooking gas. As the name suggests, natural means even without using crude oil, you can still get natural gas because it naturally occur. And it you can get it from even fowl manure. You can get it from pig manure, goat manure. You can get natural gas. Like that's why I'm calling it natural gas. It naturally form when animals release waste. In fact, you can produce natural gas too. All right. You can set up your house in such a way that you use your toilet, whatever happens in there goes one place, and you get in a few days after everything pile up, you will get natural gas. And people have used that same natural gas to cook the food by putting it in gas, and then just run a pipe to it and connect it to the stove, and you can cook food just like cooking gas. So you really don't have to buy cooking gas if you're smart. Right? Use natural gas. Natural gas has the formula CH4, really, CH4. That's one carbon there. Cooking gas has the formula C3H8. So let me just rewrite this. Yeah, it's gonna be C3H8. So right there now you're seeing where them have 1 to 4. If we can get a zoom on it. You can see where 1 to 4 carbons would give you gases, but gases with different names. The one that have one carbon has a different name from the gas that has a C4 in the formula. This is the one C4H10 is used in lighters, the cigarette lighters. This so lighter. So they're seeing these things happening in real life. These are the gases that we use in real life from crude oil. All right. So I mean, this is good knowledge for you guys, as we say. 6, 7, and 8. We probably can touch this back again next class and go deeper into it so that we can have a full understanding of these topics. And then probably focus on the other ones. If we can do it simultaneously or if we can do it separately, but one way or the other, we're going to do it. All right, guys. So any questions?
No, sir. Can't wait for next class.
Yeah, can't wait for next class. Eh? All right. That's the spirit, Arashi. All right. That's the spirit. That's the spirit. Because basically, we crack the code, I mean, I love these times, I love the times when I get near to exam and then when people get anxious. Because I am not really, I'm not anxious in the same way that person are anxious. Like people were anxious for exam, like students now go probably get panicky and get like doubtful. And I'm saying you can be anxious but not doubtful. Be confident. Be like the person who trying to outsmart. Because CXE don't set trap for themselves. Them send this. Them can them can't surprise. This must come on the paper, and if this must come, right, and the way in which them send the topics, it is so easy to pick up a hint, to read between the lines and say what is it they're really gonna send. So as I say, I'm excited because I like to find out. I really like to inquire like a detective and find out information, and so hope you guys can just be at class regularly and just follow the pattern, because you guys will be ready for the exam once you're following this. All right. I guarantee that. All right. And paper 2 is where you're going to pass that exam. And then we can deal with paper 1 afterwards. But certainly paper 2 is the thing here for us. All right. So just recap, guys. Remember, aside from 6, 7, and 8 topic, and again, I'm going to send this in the group. But aside from topic 6, 7, and 8 here, this 3 and 4 is very likely gonna be the first question. So the strategy or the tactic is that if you can do topics 3 and 4, possibly that's 25 marks. If you can do 6, 7, and 8, possibly 30 marks. Possibly 30 marks there. Minimum of 15 though, but 25 and 15 will give you 40, which is almost half of the paper. If they send 2 questions on organic chemistry that like are predicting or thinking very strong at this point, then it will be 15 and 15, 30, 30 and 25 would give you 55. And what is it saying is that, well, 55% of paper 2 would be on just 2 topics. Yeah, I'm gonna redo this though, and do. I think I did a rough thing here, and I went to redo it and think about it strongly and see if I'm going to make any adjustments here. But as I say, I strongly believe here that this 25 marks. I'll leave this one as is. Mole concept, acid base, and salt. The atomic structure, periodic table, and periodicity. That's a question by itself. Well, as well as they could merge 1, 2, and 3 as well. So, as I say, Give me some time. By next class, I'll be able to show you possibilities. It's not fully clear cut, as in it's not fully defined, but we are definitely onto something here. This we can't miss organic chemistry. That as we say, as I've been telling you for a long time, that will be there. In one question. Them can't mix these three topics with any other topic. Well, yeah, I mean, qualitative analysis probably one little question they ask about how you test for probably hydrogen or something like that. But I wouldn't even call it a real question still. It is just organic chemistry questions are usually by themselves. So that off, probably when exam time come, you might be searching for that question and the paper to do that first. Luckily, if you get two questions, you'll be so happy because you'll say, well, sir, told you this in class, and you're just going to be so excited because you know all of the possibilities there. So bam, two questions there, 30 marks in the bag. Very little you can do after that to fail the exam. I'm pretty sure that everybody in this class know basic stuff about atomic structure and the periodic table. So you could have this question in the bag as well. And then the mole concept, acid, base, and salt now might be I would say the most tricky question. But it's not, even though it's the most tricky question, it's also the question with the most past paper questions available. So that's a plus there, which means more practice. Electrochemistry can be another challenging thing too. So if I want to pick the hardest questions on the paper, it would be 3, 4, and 5. The easiest ones could possibly be 6, 7, and 8, or 1 and 2. 1 and 2 and 6 would be the easiest ones in my opinion, and 7, because them say introduction. So that part, would be easier for most students. 1, 2, 6, 7 will be the easiest one. Hardest one will be in the middle here. 3, 4, 5, and then of course non-metals, qualitative analysis is somewhere in between there. Usually, depends on what them decide to ask. But that's it. I mean, let me say, guys, just keep coming to class and if you guys meet up outside of class, or that's helpful as well. But if you meet up, then it's best to just continue with these 10 topics that you have here and focus on those. I will say, guys, this exam is for you. It's for you to do well on it. I would like for you to repeat what was done last year with IPAS students. They did pretty well last year. I mean, the 8th grade ones, then that's a record from last year. So maybe you guys can push it even more than 8. And we'll see how that work out. All right, we'll group this together. And let's see if this was a picture. No, this is like